mechanical engineering.
I'm Andrew. I'm from Greenfield, Indiana. I'm also planning on studying mechanical engineering.
I'm John from Colorado. I'm looking into electrical engineering.
Hi guys, I'm Kid. I'm from Singapore. I'm like halfway around the world in Asia. I'm looking to study either mechanical engineering or multidisciplinary engineering.
Hi guys, my name is Chris. I'm from Boston, Massachusetts, which is East Coast, and I am planning on studying aerospace engineering.
I'm Connor. I'm an actuarial science major, so I'm doing math.
I'm Megan. I'm from Colorado. I'm into physics.
So one reason why we came here today is to kind of distinguish the difference between science and engineering. So we're going to be talking about science, and we'll be talking about engineering. So science is the method by which we get information about the world around us through experimentation, as you might know. So physics deals with basically everything, the motion of things, electromagnetic actions, cosmology, biology, chemistry, actuarial science. So I like what I was hearing from all your information about yourselves, I guess. It's pretty rare that this many people know what they want to do at this point in their lives, and it's really impressive. And it's happy to know that all of you, or most of you, are engineering science. So, for those of you on the fence, I'm biased. I say go to science.
What a polymer is, it's like groups of monomers, which are basically compounds that are then compounded together to form strands, and that makes a monomer, or a polymer. And it's basically like a chain, which is, they call them a chain, so it's like taking a bunch of monomers, which would be single chains, and lining them up. And when you have a bunch of them, and they'll start like tangling together and interweaving, and the longer the chain, the more tangled it is, and that makes it harder to break apart, and so that's going to make it a stronger polymer, right? So, does anyone want to come help us? Add half a cup of water. Yeah. For every half a bottle of glue.
And this is warm water. That works better with reaction.
So explain what's happening.
So the glue has polymers already in it. That's what makes it kind of sticky and kind of tough, right? And we're adding a borax water solution, and borax acts as a catalyst with the glue polymers.
And so that's going to elongate the polymer, and it's going to make it more solid and a stronger polymer, so that way it'll actually stick together and make a solid instead of just being a liquid like it is in the glue.
And then you can just kind of stir it up until it separates really good. So right now the wire is reacting with the polymers and the glue to make monomer polymer. It makes something else. Polyvinyl acetate is what it's making right now. And then in the borax is sodium tetrabiborate, and so that's going to connect with the monomers, which is the glue, and that's going to make it longer, like I said, and it's going to make it a solid. So if you want, you can just dump it in and then if you guys can see, the glue that was on the spoon has kind of solidified and come jelly.
And you make a ball and bounce it.
So you guys know bouncy balls, like the really the clear ones, you know? Those are polymers.
Yeah.
The really dense, long polymers.
Can I? Oh.
Please, okay, real quick. Who wants to make money? Who wants to make lives better?
Lives
Wow,
better.
and make money at the same time. These are some things. So there's a lot of new kind of discoveries and kind of applications for the world around you. One of these applications is Aperture Consulting. It is a road company. It's based in Chicago. What they do is that they come into a company and they say, you know what? We think we can do this better for you. If you pay us this, we can make you more money. So if we were to say catapults, and we want to make a better catapults, if we launch this one, it doesn't go all that far. So how can we make this better? One portion of this is research using physics-based concepts. Who's taking a physics class? So one thing we want to think about when trying to innovate is what laws of physics can we apply and improve upon in order to improve the product. Some of this might be Hooke's law, in which how far back we push us back makes it launch further. Another one is the angle at which it launches can do some things for its displacement.
Right.
We also want to think about acceleration and the time that it's in the air. The longer it's in the air, the further it moves. The faster it's going, the further it moves.
So the main parts of a catapult are considerably the base, which is where you put it on the ground. And then a very important part of the catapult is the crossbow, because this is where you basically decide your angle of release, which alters the distance your ball will travel greatly. And what we also have here is the arm and the spoon, which we will use here to hold the ball and launch it with success.
Whoa.
And thus the reason we need a better design.
If I would have used extra
Time to shine, guys.
And we need volunteers if anyone.
She's the risk taker.
Okay. You don't mind getting. So go ahead and stir that up, kind of.
Yeah, just kind of like break it up. Like the glue, just break it.
So right now, the water is reacting with the polymers and the glue, and it's turning from an acid to an alcohol, actually. And once we add the borax to it, the borax acts as a catalyst with the polymers and makes them bind together to create longer polymers.
And making it longer, like you said earlier, makes it stronger. So it goes from being a solid of the glue to becoming, or a liquid of the glue to becoming a solid, and it'll bind them together, and it'll be something that you can use. Oh wait, you're not done?
Okay.
So keep stirring.
All right.
Okay. So borax is doing its thing, and it should be good.
Okay,
Oh.
and then as like because it's stronger now and it's a solid, it can still be like mended because we didn't add enough or like so much borax where it can get like really hard, which we did earlier, and so that makes it really easy to like bounce them or like do different things with like silly putty is basically what we're making.
Actually, bouncy balls, like the clear ones, are polymers. Just a very long, dense polymer.
So you can just grab that out. And just kind of like mix it, like match it together. It's like, yeah.
So in the bag is in front of you, you can take one. There's one already laying out, and that's.
Pink.
That's what a polymer is.
Here we go. There you go. There's your mark. That's a good one. Group number 3. It's time to wrap it up.
Oh, there's this 9.
Come on. Group number 3. Robotics.
9,
8, 7, 6, 5, 4, 3, 2, 1. Sometimes. Here we go.
Guys, as soon as you're done, you need to head out. I'm going to go hold the buses for you.
Yes. Here we go.
Girls rule.
1, 2, 3. Hey. Reverse. All right.